Question 1, a uniform half-meter rule is freely pivoted at the 20-centimeter mark. So the first time I did this question, I got it completely wrong because I did it as a meter ruler. So let's not make that mistake again. This is pivoted at the just away from the middle, isn't it? So this distance, some markers on for distances. This distance is 20 centimeters. Let's write it as 0.20 meters. We've got the center of mass of the ruler here, which is the weight of the ruler is acting at this point. So I'll do it W subscript R, and it's a distance of 5 centimeters from the pivot, so 0.05 meters. And then finally, we've got a weight applied on the other side. So we've got a weight of 10 newtons hung from the 4 centimeter mark, which means we could also label, let's do it in green, this distance, which is 16 centimeters, so 0.16 meters. So as a free body force diagram, this is probably reasonable. We could label the force coming from the pivot, but we don't need to because we're going to take moments around the pivot. When we do that clockwise, we've got the weight of the ruler. So that's a subscript, so let's make that clear. W subscript R acting at a distance of 0.05 meters. We're not putting the units in here, however, plus, and that's one of our moments. The other moment that we've got is anti-clockwise, so we're going to put it inside brackets with a negative sign. Force of 10 newtons at a distance of 0.16 meters from the pivot. These should equal 0. So we need to do a little bit of rearranging. Let's just give ourselves a tiny bit more room. The weight of the ruler then should be equal to, so this term is obviously minus 1.6. We're going to move it to the other side, so it becomes plus 1.6. And then we need to divide it by 0.05 so that we get the weight of the ruler on its own. Dividing by 0.05 is the same as multiplying by 20. So this should be 32 newtons, which is quite a heavy half-meter ruler. Presumably it's made out of lead or something similar.